Good afternoon, ladies and gentlemen. Thank you so much for having me join you here this afternoon to talk to you about robotics in general and a little bit about CMR Surgical and Versius, our robot. So I've set the title as Is Robotic Surgery the Answer? And I don't know that I necessarily have the answer to this question, but I'd certainly like to pose some points. For those of you that know me, I was previously head of gynecology at Cambridge University Teaching Hospital Addenbrooke's and on the member of staff, the academic staff at Cambridge University, of which I still am a member, and now working full-time as Chief Medical Officer for CMR Surgical, of which I'm also a co-founder, and has been a fantastic journey, some of which I'll tell you about today. So that starts with one of my concerns generally in life. There's a huge amount of hype in healthcare, and I think we need to be very, very careful of just accepting something because it's new, shiny, and fancy. And I think in medicine we've got ourselves into a huge amount of trouble over years adopting technologies that really don't have the proof or the substance behind them. And at the moment we hear lots of things about machine learning, big data, deep learning, AI, digital revolution, surgery 4.0, and those are good. They sound fantastic, and you hear about computers that are reading X-rays, and when you go into the depth of it, it's not quite as good as it sounds. And some of the real proponents of AI are now starting to say, be a bit careful. It maybe doesn't deliver quite as much as it does because we don't always understand what AI is, and we actually need to be able to deliver tangible, actionable, and cost-effective benefits that can make the impact now, not just in years to come. Not to ignore what's to come. That's a responsible, innovative company will look at what's to come, and we certainly have that, and we have a digital strategy, and we have a pipeline of things we're looking at. But I want to talk about what we can do today that patients will benefit from. So what's one of the big issues that needs resolving? Well, thousands of patients are harmed annually, and I'll show you a figure in a few minutes. At least 50% of surgical complications could be reduced by simple adherence to standardized care. So before we go and stick in some autonomous solution or AI or machine learning, let's just get back to the basics. Let's sort out what we can do today and improve care by volumes as much as 50%. But in order to get there, I do believe that surgery needs better tools. And that's where the devices and digital come into the equation as something we can do about this. 234 million surgical procedures annually, never an accurate figure. Go to the literature, lots of doubt. 7 million people undergoing injuries and complications, more than 1 million deaths relating to surgery per annum. So we are, in many respects, as surgeons, a WMD, weapon of mass destruction. People are dying in surgery. And the Lancet Commission on Global Surgery 2030 has identified that the need to provide decent outcomes in surgery is of a similar magnitude to the need to provide vaccinations for children in the low and middle income countries and mosquito nets for malaria in places like Africa. So it's actually recognized that if we could improve surgery in low and middle income countries and as well in upper income countries, we could save the global economy trillions of dollars in misspent health costs. And I mentioned the low and middle income countries, which is obviously terribly important. But I read a recent book by Marty Makary, who's a professor of pancreatic surgery at Johns Hopkins. And Marty is actually the man that was the original author of the WHO checklist, so somebody I admire greatly. And he's estimated that in the United States, the cost of unnecessary complications is in the vicinity of 30 to 40 billion US dollars per annum. So all these incredible savings that could be made just by getting better surgical outcomes. And one of the ways of getting a better surgical outcome is to offer our patients keyhole surgery. Now, when keyhole surgery or minimal access surgery came in, one of the big things supporting keyhole or minimal access was, you could get your patient up quicker, You could get them back to work quicker. There were less scars, i.e. better cosmesis. And at the time, I remember thinking those are fairly superficial things. And I used to, before I became a minimal access surgeon, say I wanted to know that the outcome of surgery, the answer, the result, was as good as the result from keyhole surgery before these minor outcomes became important. And fortunately, we've seen that. Keyhole surgery has been through a series of evolutions. It started in the early 90s, really in decent quantities. Had a rocky start in the beginning due to all the complications associated with poor training. And then things like LAPCO came in. There was a grabbing of the training, got better training coming in, and got therefore better results. And there are lots of randomized controlled trials that showing in the majority of cases keyhole surgery produces equivalent or better outcomes in terms of survival and patient cure than open surgery. So I think we answered that question. So then it comes to other points. Is keyhole surgery better than open when it comes to these more minor cosmetic type interventions? And I think that's an argument still worth debating in public. And if you look at complications, overall complications in keyhole surgery are roughly half the complications in open surgery across a range of surgeries, from appendectomy to lung lobectomies. And that's a staggering figure. If you can, by just converting people from open surgery to keyhole surgery, reduce your complication rate by 50%, you are just massively helping patients. And you take specific examples, a wound infection. Wound infections cost the European economy 18 billion euros per annum. The reason for that is about 50% of patients who have a wound infection will go back to hospital for readmission, and about 20% will go back to theatre to have the wound dealt with. And we all know all the hassles dealing with vac dressings and the days and wound specialists looking at it. And if we convert it to keyhole surgery, wound infections in keyhole surgery, almost no patients ever need to go back to hospital, and an unknown amount, virtually nobody ever needs to go back to theatre because most can be treated in outpatients. So that's just one single example. Incisional hernias, we tend not to see them in relation to our index surgery because the surgery happens now and the hernia happens in 2 or 3 years' time. So those stats don't get into your surgical papers, which have limited follow-up. Yet we know that in people with the right comorbidities and in certain surgeries, large wounds can be associated with incisional hernias in as high as 20% of patients undergoing surgery, yet requiring repeat surgery with all the complications that brings with it. So we see all these improvements. And this paper that I have up in front here, which is published in the British Medical Journal, really showed these real improvements in complications. So, reduction in pain, good. Quicker return to normal activity. Reduction in pain is not just about something that's good, from the patient in terms of comfort. In America, there's an opiate crisis where 75% now of new heroin users started on prescription drugs legitimately prescribed by doctors for pain. 78 people are dying every day from opiate-related overdose. And the opiate misuse in the United States costs about $78 billion, okay? And there's a huge, so if we can do something that reduces the dependency on opiates post-operatively, we may be having an enormous impact on opiate abuse internationally. And I quote the American figures, but in Europe we mustn't be complacent because there are countries in Europe that have figures as high as America and in some higher. And almost 8% of people undergoing routine elective surgery in America are still using opiates 1 year post-surgery. That's an enormous figure that we could actually reduce by using keyhole or minimal access surgery. But if it's so good, why do only a minority get it? I've just given you a whole thesis on why minimal access surgery is good. And yet, in the United States of America, the most advanced healthcare system in the world, with all the money that it spends on it, Only 2/3 of appendectomies are done by minimal access. That's the easiest operation in the world to do minimal access. It should be 100%. A third of colectomies, 13% of hysterectomies, and a third of lung lobectomies. So despite all the advantages that we've spoken about, despite all the many things that will both help the individual patient, the doctors, and the health service, these are the figures that we see in front of us, which is that only less than half of people get the minimal access surgery that would make it better. So why? Why is it so low? What are the barriers to uptake of minimal access surgery? This is a curve of from a book called Diffusion of Innovations, which is a marketing book, and it looks at how we as individuals take on new technology or new styles of living. And they divide the population into groups. These are the innovators, about 2.5% of the population. Then you get the early adopters, about 10 to 20%. Then you get the early majority, the late majority, and the laggards. And the time dependency along the x-axis is how long it takes for people. So when you bring a new surgical innovation in, about 2.5% of doctors think, wow, I really want to be part of this. And thank God for the innovators, because otherwise nothing would change. Then you get the early adopters. Now, the early adopters tend to be a little bit more sensible than the innovators. They tend to be a little bit more careful. They tend to wait for a little bit more data. And they very often are leaders in their specialties. And the early adopters then do the necessary large trials, influence people because people listen to them. And then you get to about 10% of surgeons using a technique. And that's when you go into the adoption curve, where the early majority of surgeons start to do that procedure, the late majority then pick it up, and ultimately there will always be a few people that, irrespective of how good something is, won't take it on. So we've been around with minimal access surgery since the early 90s, and yet we're only getting to 30 to 40% adoption. So we are way behind on this curve. We should be well up at 90 or so percent of it. And similarly, in robotic surgery, we have a similar story. So the thing that makes minimal access difficult is that training and acquisition is difficult. It's difficult to master. It's the old story of tapping your head and rubbing your stomach at the same time. Not easy. It's physically demanding. For somebody who's short like I am, to stand at a table, you have to stretch your arms to get across the table. The pose you have to hold is for hours. It can be difficult. We know that surgeons have a high incidence of neck injuries, a high incidence of physical pain. And we've done some work on ergonomics, just confirming these concerns about the physical demand on the surgeons. Becoming an expert takes time. If you want to learn to suture minimal access, you don't just pick up needle holders and learn to suture in an hour or so. It probably takes 30, 40, 50, 60 hours working on a simulator for a person to become really expert at it. And people have avoided doing things like suturing to use clips and staples and all sorts of other tricks that are sold as simpler and easier, possibly also more expensive, because people don't want to invest the time in acquiring these levels of expertise. And of course, some techniques just remain elusive generally. Poor access, two-dimensional vision, working in a deep dark hole in the pelvis, for example, trying to suture with these straight sticks, everything's counterintuitive, and that is probably what's led to the difficulty. So are robots the answer? And that's obviously the next question. If minimal access, and why might robots be better? Well, with robots, generally they have 3D vision, we have articulated instrumentation, and so therefore you can get better access, better vision, and is it therefore the answer? Now, robots have been around for a long time as well, since 2000, and yet only 7 to 17% of all minimal access surgery is done by robotic assistance by 2018. And the majority of these are still in urology and gynecology. So we actually did a poll of surgeons that we were dealing with, mostly minimal access surgeons, some robotic as well, to ask them why they hadn't more readily adopted robotic surgery. And they came up with a whole range of stories. They found it too expensive. They found it too big. They had to change their port positions. They had to change the way they did their operations. And this is not my views. These are the views of a substantial body of surgeons that we polled. And what they told us they wanted a robot that was suitable for all disciplines. One could be used not just by one or two surgical disciplines, but everything from the head downwards. They wanted it to be as close in cost to straight stick surgery, and I'll come back to that later. They wanted it to be high usage, small, adaptable to any theatres, modular, which would enable them to therefore replicate the straight stick story, and quick to set up and quick to take down, so that it didn't have a negative effect on theatre flow. So what is the solution? It didn't exist. We had to build our own robot. And a group of us, four colleagues and I got together with the idea to build a robot. And in many ways, that in itself is a form of insanity. Somebody asked me the other day, what's difficult about building a robot? And the answer I gave them is pretty much everything. And it doesn't get better down the line. But we decided to build a robot. We've all worked, my colleagues have worked in medical innovation, in engineering, most of their careers. And as you know, I've done a lot of innovation surgically in the past. And so it was quite a good fit for us to get together. And we actually modeled our robot on the human arm. After all, that's what we use for surgery. And what we wanted was to give you back your arm with your wrist so that you could actually do the surgery that you would do open, but with minimal access and all the advantages that comes from it. Well, we started modestly. This was our first arm. And this was the arm that Luke, one of my co-founders, made one Sunday when we'd been meeting together to explain what he thought the biggest difference was. And the biggest difference here is, as you can probably see, is that most robots are adapted from industrial robots, and they hold instruments like this, like a dagger. And whereas this robot holds instruments as we do, a knife and a fork, which gives us a greater degree of movement. So it gets 7 degrees of movement. It also makes the reach easier. If you've got a robot, an industrial robot, and you're building a car and you can't reach, very easy, you just make it bigger. Okay, but that's not a great idea in theatre, where you're limited by headspace and you're limited by the other equipment in it. So the last thing you want is a massive robot sitting, occupying your theatre if you could have it smaller. So what is it? What are the features of it? Well, this is what we call a bedside unit. This is portable and transportable. It folds up rather neatly when we press a button for it to go to sleep. That can go in a carrying case, and we can move it around the hospital, and we can move it from hospital to hospital. It obviously doesn't need a case to go around the hospital, but it does to go from hospital to hospital. Tony, my colleague here, is 5'8", so you get an idea of the size of the robot, which footprint is 38 by 38 centimeters. The surgeon works at a separate console, which is an open console. And again, we did a poll on this. We asked them whether they wanted a periscope type setup or open. Surgeons were 50-50. 100% of theatre staff said they wanted open because of better communication. And 100% of anaesthetists said they wanted open because of better communication. So we went for the open console, 3D vision. The surgeon can sit or stand, which helps the ergonomics. They sit neutrally, beautifully square shoulders, and therefore less injury and discomfort for the surgeon. You can't really see it easily here, but there are no foot pedals, and we put everything in the hand controls, much like the hand control of a helicopter or a Games Boy. So everything's with your fingers and your thumbs. We have a unique wrist design. We call it a V-wrist. This design enables the part on the front of the robot, the forearm of the robot, to rotate through 360 degrees both ways, giving you a total of 720 degrees, which actually allows you a huge amount of flexibility while operating. Because the arm rotates, we don't have to rotate the instrument, which has allowed us to build a just slightly bigger than 5mm instrument, yet still having fully articulated wrists and function. And then we describe them as being collaborative, and what that means is that we have motors in all the arms, and if Tony there wants to get a bit closer bedside to either use a manual instrument or to change instruments, he can push the elbow of the arm out of the way, and the tip of the instrument won't move at all. And the arms move very slowly. They're not like a big industrial robot who flare around a bit. They're very slow, so the staff can stand very safely alongside the arms. So we've built a fantastic robot, and I'll come back to what we've done in terms of what we've achieved with it so far. But this brings us to a point in the talk where I think it's need to say, is it a robot alone enough to change surgery? And the answer is clearly no. And so as a company, we've taken a whole lot of other innovations to go with it. So I've collaborated very closely with the IDEAL group around looking at a way of ethically introducing complex technology to surgery. A prospective randomized controlled trial is not always suitable for complex technology, but equally, just to bring it to market with no data behind it is irresponsible. So we've worked along the IDEAL collaboration to do a pattern from clinical studies on cadavers, moving to porcine studies, and then moving into clinical studies, and then finally with the introduction of a registry which measures all that's going on in our clinical program. So every patient that's operated on gets entered into our registry. So we will build up a real-world data repository from which we can actually extract real-world evidence to support the function of our robot. And I'm incredibly proud of our preclinical program, which we've now published about 8 or 9 papers in the peer-reviewed open access literature, just showing how we've moved through this process of working out port positions. And what we've shown with this is that we can do most of the robotic procedures similarly to laparoscopic procedures in a decent amount of time with quick setup and quick takedown. And the registry is very exciting because, as I'll tell you in a second, we have telemetry in our robot, and we can then link our telemetry to our clinical evidence and see ways of improving the system in due course. So how do we bring real benefits today with this sort of ecosystem I'm talking about? Well, we have a trainer, which is a digital simulator which comes attached to each one, so we improve training. We've got an app called MyVersius. You can put your videos on it, you can analyze them, that helps you get better. We digitally record the cases, we record the outcomes in the registry, and as I say, we also have the telemetry data being put down from the robots as well, so we can compare, we can look at people's hand movements to see whether, we can show the difference between a novice and an experienced surgeon. It provides you with a digital logbook, so when you come to your annual appraisal, it's all there, and you've got your results. That also enables you to benchmark against best practice, because you will get your data, but you will be shown the anonymized data of other surgeons, other hospitals, so you can compare where you sit in the zoo of surgical practice. And that also helps where surgeons possibly could have a bad run, they get adverse outcomes. That means we identify it quickly. And I don't think this is punitive to surgeons, because very often when surgeons have a bad spell, we find that they have reversible problems going on. They may be having difficulty at home, they may be having health problems, and what they possibly need to do is stand back from surgery for a while, get better, and then go back to surgery, rather than plod on, get bad outcomes, and ultimately get into trouble. So I think, and the cardiac surgeons have shown this very well with their Euroscore system, which has been in place for many, many years. So something we're trying to emulate, just generally raising the standard of surgery. And believe me, we've got away with it in the past in medicine, because as surgeons, we've always killed our patients one at a time. Okay. And now in a digital world where there are large databases, we are actually going to be scrutinized far more closely. And so let's get ready for it and be prepared. The hospitals benefit as well, because all the things I'm talking about also afford insights into the system. It improves inventory management in terms of when you need to order parts, improves governance, which I've spoken about. We think it can identify, it can give you a warning of when things in the system aren't working perfectly, so it can minimize downtime. And we can do predictive maintenance as well, because the telemetry is measuring joint wear, and it can actually show us you probably need to change something in a while. And we've got some fantastic examples of where we've identified things in clinical where we've been able to get the answer of why something happened from our telemetry. So something very exciting for the future. And that builds then this entire ecosystem with the patient fair and square at the top. Underneath it, we've got the system, we've got Versius, we've got our fancy instrumentation, we've got the trainer, then we've got a professional education scheme underneath that, doing a proficiency-based training, the field servicing and the customer service. And then underneath all of that are the dashboards, the registry, the insight, the digital offerings that we have, the MyVersius app with all your videos, supporting all these functions that I've shown you above here. So it actually starts, what the robot gives us is a digital interface. It is continuously measuring telemetry. It's giving us a new type of data. It's giving us data that if you're operating just laparoscopically, you don't have. And unless the robot's somewhere in the middle, you're losing all this hugely meaningful data, which I think is going to have such an impact on the healthcare service. I believe that we are going to see a huge increase in minimal access robotic surgery going forward. I believe that already we are at that tipping point now. I hear so many people from a range from everything from large teaching hospitals to small DGHs to small hospitals abroad who are saying that they have come to the conclusion that robotics is the way forward. And don't underestimate the intelligence of the community we work with. It doesn't always work purely on a firm evidence base. People who are practicing in the best interests of their patients, who want to get the best, are subliminally realizing that actually robot is giving better outcomes and are starting to move there. And that's from their reading of the literature and so on. So just to give you an idea about who we are, we started with, I believe we're here at an incredibly exciting time in surgery to bring minimal access surgery to many more patients with all the benefits it brings for the surgeon, the patients most importantly, and equally importantly for the healthcare system, which is to produce a value-based health system which provides good care affordably for society. And we can't just go on spending money unnecessarily. And I believe that minimal access surgery will do this. So we actually, to go back, we started in 2014. As I said, there were 5 of us. We used to meet in churches because they didn't charge you any fees, so it was free. And we met in small rooms. And then we managed to get a small amount of funding from somebody who shared our vision, who remains our biggest shareholder and funder to date. And that meant we could employ a few people, chaps could leave their day jobs. And then we managed to get a CE mark in 2019. We got a very large Series C funding round in 2019, making us one of the best funded medtech companies in Europe. And then we've grown the company hugely from then and to now, where we have more than 500 employees. We have offices in multiple geographies, and we have proceeded from our preclinical to our animal phase to proper clinical studies. And we are now operating in India. We're operating in Europe in multiple points. And most proudly of all, we're operating in the NHS, where we have 4 systems in place. And we believe that if you can get it right for the NHS, then you probably can get it right for medicine in the world. And we will soon be going into other geographies in other continents, which I can't mention, but is very exciting. And so we're at a great point of having exciting technology from a young British company who wants to work with you, the surgeons, to develop those next phases of surgery. And so I think over the next 5 years, you'll see an acceleration of robotic surgery to the point where I really do believe it will take over completely from manual laparoscopic procedures. And I hope I don't have to regret making this slide. Charles Darwin, a Cambridge boy, so I have to quote him, always said, it's not the strongest of the species that survives, nor the most intelligent, but the one most responsive to change. And I think the time for change is probably with us now. Thank you very much.